In our last lesson, we learned about different types of asymptotes and discontinuity. We had removable discontinuity and unremovable, which gave us vertical asymptotes. And then we also had horizontal, or what were called oblique asymptotes. In this lesson, we're going to use information from Chapter 5 to develop a method for finding the equation of an oblique asymptote. Now in Chapter 5, one thing we learned was division of functions. And if you carry out long division of the functions that are given, you will find the equation of an oblique asymptote. So, in this equation, 6x squared plus 4x minus 3, all divided by 2x plus 5. In order to find the oblique asymptote, since our degree of our numerator is larger than the degree of the denominator, we are going to set up a long division problem. 6x squared plus 4x minus 3 is being divided by 2x plus 5. Now remember, when doing long division of polynomials, you have to match the first value and then the others go along as is, a lot of times leaving us with the remainder. So in order to get from 6x squared dividing by 2x, we multiply by 3x. 3x times 2x is 6x squared, which is what we were looking for. 3x times 5 is 15x. Now we are going to subtract these two values. 6x squared minus 6x squared is 0. 4x minus 15x is a negative 9x. Then we bring down our 3. Now we have negative 9x. We're dividing that by 2x. That's going to give us a negative, not 9x. That's supposed to be a negative 11x. Need to do my subtraction properly. Now negative 11x divided by 2x is negative 5.5. Negative 5.5 times 2 is negative 11x. 5.5 times 5 is going to be a negative 27.5. Now we're going to subtract these lines. And negative 11x minus a negative 11x is 0. Negative 3 minus a negative 27.5 is 24.5. Now, in this case, we remove or ignore our remainder. And what we have as our as our quotient, is our oblique asymptote. So y equals 3x minus 5.5. becomes an oblique asymptote that will help structure the function. So, a quick sketch of this graph. We're going to have a vertical asymptote at a negative 2.5. Just getting a rough structure here. An equation of y equals 3x minus 5.5 will give us something like this. So our function is going to do something similar to this. And we'll learn more about how to become better at graphing these. Right now we're just learning the structure around them. Another example, if you have x squared plus 2x minus 25 all divided by x plus 5, going through and finding our oblique asymptote, again our numerator is larger than our denominator for degrees. We put our x squared plus 2x minus 25 as our dividend. Our divisor is x plus 5. And we are trying to match lead terms. So x squared divided by x is x. Make sure you're keeping place values. So we get x squared plus 5x, and we're going to subtract these. X squared minus x squared is 0. 2x minus 5x is negative 3x. Bring down our negative 25. Negative 3x divided by x is going to be a negative 3. Multiplying, we get negative 3x minus 15. And we are subtracting these from each other, giving us a remainder of a negative 10. So our oblique asymptote is y equals x minus 3. We have a vertical asymptote at x equals negative 5. So again, a quick sketch. We have vertical asymptote at -5. We have an oblique asymptote at y equals x minus 3. So here with a slope of 1. You end up with asymptotes that look like this. And we're in the positive quadrant, so we have a function that's going to look roughly like this. So a lot of things can be done with this, but finding the oblique asymptotes, if you have a cubic being divided by a linear, your oblique asymptote can actually be a quadratic function. So keep this in mind as you move forward, and it'll help structure your graphs.